Welcome back. Welcome to lecture 25 of Financial Mathematics for Actuaries. This is the last lecture of week 5. So, we will deal with problem solving of complex streams of payments. So far, whatever we did in weeks 1 to 4, it was very clean. We roughly had single eye, we had regular timings, and even if we had some messy calculations, they were generally streamlined by doing some minor changes. In today's lab, we are going to handle this messy reality of the real world, where the rates can change halfway through. You may use deferred perpetuities, so you want the payments to be forever, but you may want to delay the payments, or you may want to deal with hybrid systems. Some systems are having discrete payments, some systems are having continuous payments. How to handle all these together? That's what we will do today. So let us take the first problem, which will actually tell you how to handle the split rates, the changes in the interest rates that happen halfway through. Okay, so here is the scenario of changing economy. You have an investment. This investment pays you $100 at the end of each year forever. So this is a perpetuity. Years 1 to 10, the interest rate is 6%. However, years 11 onwards, the interest rate has actually risen to 8%. Now, I want to calculate the present value of this stream. How will you do that? Pause the video, try yourself, and then let us check the solution together on the other end of the video. Welcome back. I hope you must have tried. Let us see the solution now. So here we need to strategize. We need to split these two things into separate zones. So here is the block method that we will use. So in the block A, we will deal with the annuity for first 10 years where the interest rate is 6%. In the zone 2, we will deal with the perpetuity which will be there from 11th year onwards, right? So this is our block B of perpetuity. What matters is what is a value at t is equal to 10. We need to determine that value. Okay. So we will develop a strategy around this. Once we determine this value at 10, which is essentially coming from the block B, which is the perpetuity, and then we will discount this value by 6% and take it to the local zone, which is 0. Okay, and while taking home this lump sum which we accrued at 8% by reverse engineering, we will discount it by 6% and push it to 0. So this is where the crucial trick of this problem is. So we will do that one by one now. Let us handle this block A first. So the first 10 years are very clear. I have 6% interest rate and I know how to calculate annuity for that, right? So it's you are already familiar. For completeness, I will write 1 minus v raised to n upon I. That's the formula that I will deploy, and this is going to be a n. Okay, so the 8, 10, 6, n becomes 10, I becomes 6%, and you apply that formula, you will get this factor. Multiply it with 100, you get this answer. So it's very clean, there is no confusion here. The confusion will start from block B. Actually, block B in itself is not confusion, we can easily calculate. We want to know the value at t is equal to 10, right? So this is where we have. So from 10th year onwards, the interest rate has changed. The interest rate is 8%. Therefore, the perpetuity that I am calculating for 100 per month per year will be 1 by I, right? So 100 into 1 by I will be multiplied. That I is 8%. So 100 by 0.08. So the value at time point 10 is 1250. If I do this, Okay, now this is a value at time point 10. I need to bring this value to time point 0, right? But between this zone 10 to 0, the interest rate was 6%. So that is what I need to take into account. So my discounting factor should accommodate this 6%, not 8%. So that's why this discounting factor accommodating 6% is 1.06 raised to minus 10, okay, for 10 years, and that gives me the 698. Okay, so what should be the total present value? Present value of A plus present value of B should give me the total present value. So that's what we will do next, and that will be 1434.01. Okay, so we have solved the changing economy problem. Now no matter how many economy changes are there, the procedure is still similar. So you can solve any changing economy problem using this. Okay, so now let us move on to the next problem, which is problem 2. It's called patent royalty problem. So what is the problem here? You have been granted a patent which will take 5 years time. So you will be granted a patent in 5 years time. Once granted, this patent generates annual income of $50,000 on a continuous basis for next 15 years. The force of interest in this problem is given to be 5%. The question is how to calculate present value for today. Okay, try your hand. This is a problem of deferred annuity and you are using force of interest, so continuous annuity will be in play. Okay, so pause the video, solve the problem. On the other side, I will solve the problem with you. Welcome back. So let us see the basic understanding of this problem, where the patent actually is granted after 5 years, right? So I have to defer my annuity by 5 years. Apart from that, there is a continuous flow of next 15 years, right? So everything is set for me. This is a deferred annuity problem. So I will look at the value at time point 5 and then I will discount it backwards. That should be my strategy. Okay, so let us take the step 1. Let us look at the value at time point 5. At time point 5, this is simply a continuous annuity problem which is having force of interest 5. So 1 plus I is equivalent to e raised to delta. So this phi is actually 0.05 and therefore 1 upon 1 plus I, which is V, is e raised to minus 0.05. That is what is reflected here, correct? And then it is multiplied by time period, which is 15. So that's gone. So 1 minus e raised to minus n delta, that's what is this, upon the delta factor will come in. So this is delta factor. So I am using that formula, 1 minus e raised to minus n delta upon delta is the continuous annuity for n periods. That is the formula that is being used here. Okay. Then multiplied by 50,000, which is per year, per annum income for 15 years. So just solve this. This is the value at 5 is given by this, correct? Now what I need to do? I need to bring it back to the original value, which is 0 at time point 0. So what should be the transformation? In general, we use this v to the power minus m, right? So that's the idea. So v to the power m. So we will add that transformation, and the m is here 5 years. Okay. So when I multiply this value with v to the power m, what is v here? E raised to minus delta, which is e raised to minus 0.05. I get this value, which is 4,10,921.30. Done. So we have solved the problem. Let us move on to the next problem, which is slightly tricky. It's it's called layer cake, but let us see why it is called layer cake. A donor funds dollar 10,000 per year scholarship forever. Okay. However, for the first 5 years or the first 5 payments, they want it to be dollar 20,000 to attract many people. So, to kickstart the program, right? The interest rate is 5% and you have to find the total donation required right now. Okay. So, how will you see this? You can either see this as 5-year 20,000 annuity, and then you can take after 5 years this will be converted into 10,000 10,000 perpetuity. That is one way, or you can have one intelligent way in handling this is you can have one perpetuity which is going for 10,000 forever and another one which is going for 5 years. You can have both options. Now pause the video, try to solve the problem, and on the other side I will show you one solution. Welcome back. So let us look at the later option that I have given. So here, instead of splitting the time between years 1 to 5 and then 6 onwards, we will split by amount. So here is the first layer of annuities. It's called, it's perpetuity because it is continuing forever. So that will be same 10k forever, and now we will top this up with the layer 2, which is the 10k bonus for first 5 years, right. So how to calculate the present value? So present value will be present value of base perpetuity, which is in blue, and present value of the bonus annuity, which is in yellow. Okay. So we will calculate these two and we will sum them up. That gives me the total present value, which is very straightforward and clean calculation. You do not have to actually remember any other formula than formulas for perpetuity and annuity. Okay. So let us look at the base perpetuity. 1 by I, 5% was the interest rate, 10,000 by 0.05, you need 2 lakh. Now let us look at the layer 2, which is the bonus annuity, which is again 10,000, and I want the annuity, so it is phi, a phi into 5%. So it is 1 minus v raised to n upon I. So that you can easily calculate and you will get the answer to be 43,295. Final answer is sum of these two. So it becomes 2,43,295. Wonderful. So we have solved this problem also. Now only one is remaining, that is problem 4, and that should be very easy for you. This is finding the wait time. So essentially I want to find n. So let us see what is the problem. You invest $50,000 today at 6%. You want to withdraw this 8,000 per year forever. So you want to convert this 50,000 invested today into a perpetuity of 8,000 per year forever. But here is a problem. So if you simply take this 8,000 and you calculate this 6% of this 50,000, what you get is just $3,000 per year. So this money, that 50,000 that you have invested, is not good enough to give you 8,000 per year, but there is the power of compounding. So can I wait for some time and get this 8,000 per year forever? If that is the case, how long I need to wait, right? So that converts into a question that how many years I must wait. So it's deferred annuity problem, deferred perpetuity problem in particular. So you just figure out what is the differing period. Okay. On the other side, I will show you the solution. So pause the video and try to solve the problem. Okay, welcome back. So here the main thing is I need to understand this 50,000 is growing at the rate of 6%, right. So my target should be something that will give me $8,000 per year, right. So what is that amount for getting that $8,000 per year? That's what I need to calculate, and that will set my target. So that is what I will display in the solution part. So when I want to set my support for 8K, what is the golden goose that I need to fund? That's what we are looking for. So it's 1 by I, right. So 1 by I is 1 by 0.06, and I will multiply that number with 8,000. That gives me a number which is my target, 1,33,333. That is my target principal. That's the golden goose that I need to fund. So I will go ahead and set that target. Now I need to check whatever 50K I have invested, I am asking for this money to do more than 2x, right, more than double. So 133K it has to become. So how will I figure that out? That's a very easy problem, right. So we can actually do that in a very easy way. We can simply put this 50,000 and multiply by that interest rate raised to m, and that will give me the set target, correct. So it's a equation of value, so that we have set, and now you have to find that m, right. So you do all the algebra, take some things here and there, divide by 50,000, you get this. That because m is in the exponent, you have to take ln, that is your natural tool. So you get ln of 2.6667 upon ln of 1.06, and that roughly comes out to be 16.83 years. That means if you invest 50K today, to get $8,000 per year as perpetuity, you need to wait for roughly 17 years to reach that critical mass where the fund will pay you $8,000, right. So this is the interpretation of today's class. So wonderful, we have solved 4 difficult problems which turned out to be very easy problems. So let us summarize what we have learnt in this particular session and in week 5. So we have actually mastered the timeline. We have split rates, which is the changing economy. We looked at the value of at border and we discounted with first rate. We looked at continuous payment streams, and then we used delta integration logic. We also dealt with complex flows where we are stacking one layer over the other, and that is the layer cake problem, or you can slice in time blocks and you can find the answers. Both will match. You have also seen how to keep decimal places in multi-step problems, and that is about annuities, perpetuities, and various different scenarios. Now, what if you add one more level of complexity, that is varying annuities? Your payments will grow arithmetically or geometrically, because I want to capture inflation. So I need to do this. So that is the next issue that we will handle in week 6. In week 6 we will handle these varying annuities. See you in the next week. Thank you for making through week 5. Solve all the assignments of week 5 and meet me in week 6. Thank you.